Good afternoon, everybody. How are all my dependency property data binding loving friends? Good? Yes. Well, welcome to the after lunch session here. My name is Tim Hewer. This is Harini Kannan. We are program managers on the XAML team, the native UI platform for Windows. And we are here to talk to you today about responsive UI in XAML, what we've done for free for you, what you can do for developers. You've heard a lot about this throughout today and yesterday in the keynote. Saw a great keynote demonstration this morning that Kevin was able to do, demonstrating a lot of the things that we're hoping to go a little bit deeper in and hopefully answer some questions for you as we go through. As a reminder, please feel free to fill out the evals. Now would be a perfect time. You can go ahead and put 5s across the board, and then we'll wait. It's OK. But go ahead and fill out the evals. If you haven't downloaded the mobile app, that's actually the easiest way to do it. It's available on all platforms, and just go ahead and do that. So as you heard from the keynote yesterday and today, Windows 10 represents a great opportunity for you, the developers, to create on this universal Windows platform, this single platform that allows you to target all of these multiple device families, and allowing you to create one code base, or one application that targets all of the devices that Windows has to offer, from the standpoint of the classic desktop PC to the mobile phone to HoloLens that we've been seeing those crazy, crazy demos about, IoT, and anywhere where Windows is going in the future. This universal Windows platform is the one place that you want to target. So the UWP, the acronym Universal Windows Platform, becomes the one set of core APIs that you as a developer have to really focus on to target all these Windows device endpoints. So as such, we're only allowed to use approved art. So this was the most guy that I could find in our approved artwork that just looked like, yeah, really, OK, what does it mean to me? So we'll be seeing our friend here, the pessimistic developer. That's what he looks like. This is all great, and the marketing message is fantastic, and hopefully you've seen through the demos that it actually can be proven, but what does it actually mean to you? So this session, we want to talk about from a UI perspective. We're going to touch a little bit briefly on some non-UI things, but mostly ours is really focused on the UI, so the view aspect of your application, what your users will interact with, and what you'll show on those various screens. And we believe this is the core message we want to get to you in this session, is that from a UI standpoint, we believe that a large, if not all, of your key scenarios can be met with creating a single app and within single views that use the APIs that we'll be able to show you, that responds simply to window size, and if necessary, and only if necessary, checking for feature detection or capabilities. And so hopefully we'll be able to demonstrate that to you today. So what have we done in XAML? So we wanted to break this out into a couple kind of conversations today. We've done a couple things that you've seen a couple times here of what XAML or what the UI framework does for you for free. And we're going to reiterate those and highlight a couple of those. So this is just by using the Universal Windows Platform version 10, you're going to get all of these things for free. And just by using the common controls and things like that, you'll not have to do anything and be able to have an app that responds to different user input and different screen sizes automatically. Then the second thing we want to demonstrate is what are the new APIs that we've provided in the XAML framework that allow you to kind of go that next level deep and really kind of start to tailor your application. And then as such, we want to demonstrate that XAML continues its extensibility platform and show you some ways that you can extend those things that we're going to show for your own specific needs. And if there's things that are out of the box that don't meet your needs, how you can fill those. And of course, there's going to be some of you that are in the crowd that want highly tailored information that, get out of my way, give me the keys to the kingdom. And so we'll briefly touch on that as well. So let's first talk about what do you get for free. We've seen this picture. We've decided not to actually go in some of the demos. So if you're using Windows 10, if you're using context menus in the shell, even in File Explorer, you see this as well. This is an example of input kind of responsiveness or adaptation. So when you're using the menu flyout control in XAML, if it was invoked via mouse, we have a denser hit target for those kind of precise input instruments, such as pen and mouse. And invoked via touch, we have wider hit targets. And this is just something that you get for free. You don't have to do that. You don't have to think about that logic. Likewise, in the pivot control was mentioned. So pivot is one of those controls that was now on the Universal platform. It was previously only available on the phone platform, but now available across all the Windows 10 device endpoints. And so pivot, what we've done in pivot is it itself is a responsive control. So you see here on the screen I have, looks like 1, 2, 3, 4, 5, 6 pivot items there, with artist being the one that's currently selected. Now, what we've done in the pivot control is we've already done the kind of window work, and we say, hey, if all of those pivot headers can be viewed on the screen, on the current window that's being presented where the pivot is, or the container, I should say, then we'll go ahead and show them in order, so you kind of get this tab-like experience. Users of the Windows Phone will note that the pivot experience was always kind of a leftmost experience, was the selected item. So we've actually incorporated that into the design language as well. So here, the window is wide enough to show all of the pivots and still have the selected one in the middle. Now, as I resize the window, you'll notice that the artist selection now is at the leftmost, and we kind of go into that classic Windows Phone pivot model, where we've decided that we can't show all the pivot items, so we still want to have that pivot experience. So you can still swipe left and right, and you'll notice that artist now is the leftmost, and if I were to tap songs in this case, it would go to the leftmost. And then you might ask yourself, well, how do I get to those that are invisible? And again, we've added that keyboard capability, so you don't have to think about that as well. So if a user is a mouse or keyboard user, as they would hover over those pivot items, they would get those visuals to be able to kind of toggle back and forth through those pivot items. So this is a great thing of something that the XAML framework does for you that you don't have to think about. These are just 2 examples. Combo Box is actually another example that always has been this way. If you invoke it via touch, you kind of get that carouseling effect where the items just kind of roll over, versus if you invoke it via mouse, it is a classic Combo Box capability. So we already we're starting to think about that in Windows 8 and have some of those, but we're just kind of evolving that throughout the controls that we have now. Another thing that you get for free in the platform is the concept of scaling. Now, this is something that most people don't have to think about. We have added new scale factors to the Universal Windows platform. There's a session that's referred to there that talks about this much more in depth. But for XAML, we will do the scaling for you. So if you hit a certain high DPI plateau, your app will just scale appropriately, and fonts and everything will look correct. The only reason why we call this out is the thing that you need to do is if you have assets, specific assets, most likely like bitmap assets, that's the area where you need to think about it. And as long as you structure your assets correctly for the scale factors and for the most important ones that we call out here, or we believe the most important ones, then again, that's something that the platform will do for you for free. We'll just automatically pick those assets. You don't have to actually think about them. But for the most part, we think very few people will fall into these, especially XAML developers who use a lot of vector. Those automatically will scale for you. So let's talk about that next level. How do we enable easier responsive UI for you, the XAML developer? We wanted to be able to do things that XAML developers like to do to be more productive in markup. Ironically, a lot of the things that we've introduced in Windows 10 for XAML are things that you can do today. You just have to write a little bit more code, and we've heard the feedback that people like angle brackets, so we're here to bring you more angle brackets. In the most performant way, that's the challenge for us. So we want to make sure that you can do these, responding to these window-sized things in markup versus just having to write code to that. That's the first and foremost thing that we wanted to do. Second thing, we wanted to introduce some new ways to lay out things a little bit easier, and also in combination with those, the things that we'll show, making that layout be able to change a little bit easier as well. So we'll introduce some new APIs there. And lastly, we wanted to talk about some of the building blocks that we have that enable some of these responsive patterns. And if you went to Jeff Arnold's and Carmen's LaTeX session yesterday, they talked about a lot of these app patterns. And we wanted to show one of the controls that serves as a building blocks for some of these app patterns. So we love our Windows Insiders, and as a part of that, we decided to use a Windows Insiders app to actually demonstrate some of these things. So we are using a Windows Phone app called Cleva. Cleva is a Belgian word, I believe, for, not Belgian, I'm getting that wrong. Swedish word for climb. And so my friend Glenn and Diani wrote this app as a Windows Phone app. And I had to put people in circles, right? That's the rule. So we got to put people in circles. So, so Glenn was nice enough to let us use the app and hopefully do not a horrible job demonstrating some changes that we think that we can. So this is a phone-only app, and we're going to make it a UWP app and then add some responsive UI to it. So thank you, Glenn, for letting us use that app. It's a free app. You can download it today. So with that, I'll turn the time over to Harini, who's going to start demonstrating that first layer, the core building blocks that we have.
Sure. So thanks, Tim, for the plug. Hopefully, I'll not do a poor job at porting this app into a UWP app. So here is the app you have today. It's the Cleva app, and this is the Windows Phone app that exists today. It's an 8.1 app. And you can see that, I'm just going to look at a couple of, UI here so that I can show you what it looks like, and then we'll see what kind of experience it becomes once it becomes a UWP app out of the box. So it's basically a Strava client. My friends are just Tim, and you will have the feed from Tim and me. You will see that Tim is killing it on the bike these days. And each of these feeds, it's kind of has activities, and each of these activities has some details to it. So it's a simple app. And once you've seen this Windows Phone 8.1 app, I just want to show you what it looks like out of the box when we convert it into a UWP app. Sam Jarawan has a session tomorrow which talks about some of the techniques that you can use to actually port your app if you have an existing Windows 8.1 or an Windows Phone 8.1 app. I've used one of those techniques here. I'm not going to go into a lot of detail here, but basically what I've done is basically create a second project into my solution for UWP, that's a new name. And inside that, I just brought in all the views and references that were there in my Windows Phone app, and anything that was that I wanted to be shared, it's inside the shared folder, similar to how we had it in Mercury in Windows 8.1. So once I had this simple, the simple as-is port, I'll show you what it looks like when it runs on the desktop, because now with Windows 10, this app is now capable of running out of the box on the desktop. As you can see, everything works in the sense that you get everything for free. All the UI elements are there. The data is there for free. And the things that you're probably going to be missing a little bit are the optimizations that you can probably have to account for a bigger window and the resizing windows when it's run on the desktop, for example. This app was created and optimized for the phone, so it is going to have some very fixed layouts and fixed, for example, this image here is kind of very fixed to a certain width. So it doesn't really scale well. When I maximize this window, it looks pretty, it's not very great. So how do I make this a little better? I'm going to walk you through three techniques here. The first one is actually a split view control that we have introduced. This is the kind of an adaptive navigation pattern enabling control. It's a little flexible in that the split view is going to be, it's basically a split view. You have a pane, and then you'll have its content. The split view's pane has a couple of properties in there. The display mode property has 4 different settings that you can use, which are inline, overlay, compact inline, and compact overlay. By setting, toggling between these properties, you can actually collapse the pane smaller and smaller as your scenario needs. The split view's pane can be open or closed. And you can also set the pane's width based on whether it's the open pane or the compact pane. Each of those can be altered as per your needs as well. So once you have the pane, typically these kind of, we picked this app because, it kind of very beautifully illustrated the split view scenario that we wanted to show, which is basically a list which drives some details from each of those items in the list. So in order for me to actually build a single UI which could scale between my smallest phone and the largest desktop, it is a very enabling scenario for me to use a split view, because here I can actually encompass both of those UI pages within a single view and then just toggle between them as I need it. So here, as you can see, the split view's pane has the list, and the split view's content is going to be the main content, which would get the data. As soon as I select an item from the list, it's going to display that particular detail in my split view. So let me very quickly show you what this app now looks like once I incorporate a split view in it. So this is the app. As you can see, I have made the split view's display mode to be overlay, and the pane is set to be not open. So when I see the app right now, so this is my pane. It's in overlay mode where it actually overlays on top of the content. And when I select a particular item, I get that item's detail over here. this, once again, I mean, we have used the split view control, but you can once again see that there's a little bit of more optimization I can do to make sure that I use this screen space more effectively. So in order to do that, I'm going to introduce a second API that we have added, which is an improvement to Visual State Manager. Let me add a quick snippet and then walk you through it. So Visual State Manager is a class that has already existed in XAML. What we have introduced is two APIs in it called state triggers and setters. So visualstate.stateTriggers has an inbuilt trigger called adaptive trigger, which is going to be keyed off of window width and window height. Like Tim mentioned, we believe that most of your adaptability UI scenarios are going to be served based on window sizes. So as long as you're thinking about your UI in terms of effective pixels and you're kind of building out such that you're, the largest windows and you start resizing them into smaller windows, and that's going to automatically translate into smaller phones and phablets and all of that stuff, you don't necessarily have to think about form factors unless you have a scenario for it. So in this particular scenario, what I'm doing is I'm using the adaptive trigger inline markup statement to say that when my window width is anything greater than or equal to 720 effective pixels, at that point, this particular statement is telling the framework to apply this visual state. Previously, in Windows 8 and 8.1, what you would have had to do is write some code behind and handle window size changed events and then say, go to state and call a particular state. So like Tim mentioned, we are trying to do a lot of these things in markup such that it's going to be pretty easy for you to just declaratively and intuitively just say a single line, and then that's it. You're good to go. Similarly, with the setter syntax, we have kind of made it a little bit easier for you to make some discrete property changes in markup. Previously, you had to write storyboards with a lot of verbose animations and where you did not need to lose animation at all. Even for a key time 0 duration, you had to write an animation code. Instead of that, what we have done is you can have now a setter syntax and say, in my target element dot the property name, and set the value to the value that you want to be applied when this state is applied. So basically, in this combination, what you're saying is, when the window width is anything greater than or equal to 720 effective pixels, please make my split views pane to be open, make it inline, and change the pane's length to be a little greater than width so that I can actually account for better space here. Thank you. I'm going to proceed and show you the third improvement that we've introduced before I actually run and show how this app looks like, because we don't have a lot of time. So the third thing that I want to show is actually the relative panel control. For that, let me first show you this app. So the thing that I'm going to talk about is just look at this items panel control. So each of these is an items template. So each of these is probably a data template you're used to. The way I have structured it in this app is to use a user control and then just use it inside the data template. So in my user control, so if you can see, this particular small UI, it has probably like around 10 elements in it. It has a profile picture, there's an ellipse here, there are a couple of text blocks here, there's a map image that kind of stretches across, and there are a couple of icons here. And there are like rectangles at the top and bottom. So there are like around 10 elements here. And in order for me to actually lay this out in this kind of it's a little bit of a complex, it's a composite UI. It's not a straightforward layering of elements. In order for me to actually do this, when we actually took the app from our MVPs, this is kind of how it looked like to actually structure that particular user control. As you can see, to put 10 elements on the screen, they needed 1, 2, 3, all 3 grids nested inside each of them. And we have a couple of stack panels inside there, and a 4th grid with other more stack panels, a whole lot of complex UI in here. So the markup, I cannot look at this markup and then envision what it actually looks like, and it just doesn't correspond for me. So one of the things that we have introduced, before getting that, so there are 2 reasons why this is problematic. The first reason is that, especially in some kind of a repeater scenario like this, where you have like at least 20 to 25 instances of this kind of an item control over here, the more number of panels you add, the more number of UI elements you have, your performance is going to be hit a little bit worse. And the second reason why this is a little bit problematic is because with these adaptability scenarios where you now want to account for larger space and lesser space and things like that, if I wanted to move one of these items around, say, for example, I wanted to change this kind of the activity date time that is showing here, the on Wednesday text block, I want to move this position to be from, when I have more space, I want it to be at the top right of this panel, and then when it's a little lesser space, I want it to actually be positioned next to the athlete's name. In order for me to do that, when I have so many complex nested grids and stack panels, it is going to be a lot of hairy code. I would either have to create like super grids and have extra rows and columns that I just move things around, or I probably have to remove, unparent a stack panel from one grid and then put them in another place, maybe write code for it, or whatever it is. It's going to be hairy. So both these problems are being addressed by this new control that we have introduced called relative panel. What I'm going to do is completely get rid of this guy. I don't need any of this. And I'm just going to add a snippet for relative panel. And you can see that all the items inside this are the 10 elements that we are actually putting on the screen. The relative panel is a constraint-based layout mechanism that we have introduced that actually helps you to position elements on the screen by establishing relationships between elements as well as between the element and its container panel. So for example, here you see the map image, which is this guy that is running, it's stretching from the top to the bottom to the left to the right of the panel. It's completely stretching across the panel. So what do I have to do? I have to set the relationship properties on this map image to be aligned bottom with panel, align left with panel, align right with panel, and align top with panel equals true. So once I set all these 4 properties, it means that this map image is going to be stretched across the 4 edges of the panel itself. Another type of relationship is going to be like a sibling relationship between elements. So for that, I would like you to take a look at this guy. So the activity name, if you see the UI, the activity name, if you had to look at this UI and think of where it is positioned, you would say that it is to the right of this profile picture. And it's at the top of the panel, right? So that's exactly the kind of code you would have to write. You say align top with panel equals true, and a relative panel.write off equals profile pic. And it's as simple as that. So once you have this kind of UI that you're able to write, you're now able to very intuitively create UI by just positioning elements without needing. You're not forced to create nested panels if you don't need to. Once again, I'm not saying that nested panels are bad. If you want, you can always put a stack panel inside. If that's more intuitive to you, please go ahead. Grid has its scenarios, stack has its scenarios, but you're not going to be forced to do that with a relative panel. You can create kind of complex scenarios like this with a little more ease. Awesome. Thank you. So the second problem that I was talking about, and I want to show it addressed before I actually run this app and show it to you, is to move an element around, how easy it is to do with relative panel and with adaptive triggers. So the scenario that I was talking about is the one that I'm going to build out, which is I'm going to move this activity date time text block to be at the right and the top, and I have enough space, and then I'm going to move it to be next to the athlete's name when I have lesser space. So the way I'm going to do it is by using the similar strategies that I just showed you, which is using the Visual State Manager's adaptive triggers. So here, I would like you to see that I'm creating 2 states. I will come, in a minute, I'll be talking about why I need 2 states here. For now, let's focus on the first state, which is exactly the same state that we had in the previous one, which is when the window width is anything greater than or equal to 720 effective pixels. I want the panel's size to be a little bit bigger. And when it is bigger, I also want the activity date time to be aligned top right, as well as make the activity name to be left off the activity date time. So this is very similar to the other Visual State Manager syntax that we just saw in main page. What I want you to see is the other state that I have here, which is a second state, which is an explicit state which talks about the window width when it is anything from 0 to 720 effective pixels. So this state will be applied when the window is anything less than 720 effective pixels. And the reason why I want to have 2 explicit states, especially for relative panel, is because when we actually don't have an explicit state, what happens is that when this state is no longer true, the framework automatically unapplies any property that was set within this state and goes back to default markup. So in our main page, when we had only one state, when the window is anything less than 720 effective pixels in width, these values are automatically unset, and I go back to default markup, which is overlay and pane closed. So this is an easy scenario for me when I'm targeting the same exact properties, and they're getting overwritten for me using a visual state. However, when we use relative panel, more often than not, the properties that you're going to set for relationships are going to be very different. Here, I'm constraining I'm constraining the activity names left off property to be of certain value. But when I'm actually moving it around, I'm setting the activity names aligned right with panel equals true. So it's a very different kind of properties that I'm going to be targeting. So in this case, if I don't have an explicit state, the default markup and the visual state might have conflicts. So if you are actually trying to use relative panel to move your items around, this is a recommended approach for you to actually have explicit states and actually create constraints within those states. So now that we have all of these 3 scenarios built out, let me quickly run this app. I say quickly, we'll see. And I'll show you what the app now looks like with these 3 techniques applied to it. OK, there it goes. Excellent. So now you can see that we have the, right now the Windows effective pixel width is probably greater than 720 effective pixels. At this point, my split view pane is inline, and it has a wider width. You can see that as I start collapsing it, it goes into overlay mode. And when it is in overlay mode, each item control, if you notice the daytime text block, it got moved to be next to Tim Hewer. And if I increase the width, you'll see that it goes back to at the top right. So all 3 techniques came together, and we now have a much better looking UI for our desktop. Before I hand it back to Tim, the one thing that I do want to show is that I want to deploy this app after we have added these responsive techniques to my phone and show you that without actually trying to look for whether this is a phone or not, or whether doing a device characteristic, all I had to think about was size and windows and effective pixels, and now I have an app that actually works well from my smallest phone to a big window on the desktop. Deploy has started, and soon. So basically, what I'm expecting to see is that every visual state that I have that is anything that is not about a window width of greater than 720 effective pixels, those states need to be applied on my app when it is on the phone. Excellent. All right. So you can see, so right now the app is showing the activity details in one, and the split views pane is in overlay mode. When it is in overlay mode, it looks like it's navigating between 2 pages, but whereas it is actually the same page with 2 different views collapsed. With that, I'll hand it back to Tim.
So what we just demonstrated was kind of the 3 key features that we enabled in XAML this release to hopefully make it easier for you to do things right out of the box. The first one being, just to recap, the first one being the visual state triggers. And looking at the code snippet here, pointing out that we are shipping in the box this adaptive trigger that responds to the window size, which again, we believe is a key factor in determining these things. And so the key points for the triggers that we want to get across, this is kind of like a media queries aspect for native frameworks. And it responds to a condition that you define and goes to that state and then applies those rules. So this is a declarative way of doing something that you could have already done in code. And like I said, we're shipping that first one, the adaptive trigger, in the box for you. And then the second thing that we showed was the Visual Studio, or the Visual State setters. This was kind of be the before. So we see a lot of zero-based discrete changes. And so we wanted to streamline that. And so we created what we feel is a better syntax of making that line of code down to a much smaller chunk of just saying, hey, I just want to set these values. I'm not really animating them at all. Then the last thing we showed was, or one of the last things we showed was relative panel, which is this new panel for us to define more of a constraint-based layout for your UI elements, defining relationships with those UI elements in spatial order with each other or with the panel itself. These leverage, when you use the kind of below and right of aspects, these leverage X-named elements primarily. So for the relative to the above and below kind of positionings for those things. So here was the example of the snippet that we had of these elements here, and kind of just pointing out a couple of the examples of where we used what Harini showed. And so some of the properties that you'll see in the relative panel as far as the spatial aspects is above, below, left of, right of probably their X-named elements, and also with the kind of aligned star width elements. And so the star is the top, bottom, left, right, and horizontal center and vertical center. And then we also are introducing the split view control. So that we see this as a building block for some of these responsive UI elements and transient content. Again, talking about Jeff and Carmen's session, this is one control that could be used to use the hamburger navigation pattern. It doesn't only have to serve that purpose for you, but it can be used to kind of help those navigational patterns here. And it will help with some of those responsive UI patterns of going from small to large screen there. And we support an overlay mode and these various inline and compact modes for you. This is an example of the breakout of the screen that we showed and what the pane and the content would look like on the split view. So there's basically kind of two empty content areas that you can put your stuff there. So moving forward, let's bring back our friend Pessimistic Developer. And I really want to do a Game of Thrones meme here, but again, licensed content, so I made my own. So I know that a lot of you guys in here are probably saying, that's great, all this built-in stuff, but one simply does not use built-in features, right? We must extend what we provide. So we're here to provide that for you. So there's a couple things that we think that people will want to, that have questions in your mind of like, well, how do I adapt my UI under certain conditions? One of those things that we will call out is feature detection. This is one of those non-UI capabilities that actually Brent Rector has a session that's more in-depth, and we have a referral to that at the end of this slide deck. But feature detection is basically an API type-based mechanism for you to basically say, hey, is this API I want to use available? Now, for the most part, we think that we've converged a lot of the APIs, so this should be very, very small cases where you need this. In fact, we really struggled on a real-world scenario where this could be met. A lot of people use the hardware back button, but there actually is a converged API for that now. So just as an example here of what you use is, let's say you wanted to provide some like haptic feedback, and maybe a desktop PC doesn't have a vibration device. So this is an example of how you could use a feature detection. Much like when you're developing for the web, you shouldn't be checking browsers and specific browsers or browser versions. You should be checking if a capability exists that you want to use. And that's the thing that we want to get across here. But again, we feel that these are very small cases that you will have to use these. But again, Brent has a section more in depth on that. So let's talk about triggers. We mentioned that we're shipping an adaptive trigger in the box, and I'm sure a lot of you guys are thinking about, okay, well that may not be enough for me, and I want more, and I see Laurent here, and he's already thinking MVVM, and how do I get all this stuff going and everything. So we want to say, we are providing a capability to extend the trigger concepts to whatever your need is. So with that, we'll jump right into the demo of extending the triggers.
Awesome. So in order to extend your triggers, there are going to be, I'm going to walk through two scenarios, actually. There are two ways where we have kind of opened up the state trigger base class, and you can now actually create custom triggers. The first one, to go through that, I'm going to actually use a view model property where, in this particular case, the activity feed, every activity detail has a view model property, which is a Boolean property called whether it's commute-based or not. So whenever it's a commute-based activity, I want to have a different kind of UI for it, maybe highlight the UI a little bit. So in order to build something like that, all I have to do is just use state trigger inline inside my Visual State.state triggers, and then set the isActive to and bind it to the actual Boolean property in my view model. So without having to write a bit of code, I can now actually bind to a Boolean property in my view model and create a custom trigger, which would actually change my UI elements for me, where I'm kind of highlighting a little bit and saying, whenever there is a commute-based activity, show me a little highlight and show that it's a little different activity that I can see. So this is the first way that you can actually extend state triggers. The second one is a more involved scenario where I want to actually show you how to implement your own custom trigger. For that, I'm going to actually go back. I have a basic input type trigger class that I've already created that I'm going to start adding code into, and then I'll walk you through it. The scenario that I'm going for here is that in my activities, for example, here, there are a lot of times where I want to adapt based on the input that the user is using to interact with my app. In this case, this kind of list of activities is pretty long. I might get to a bottom of the list, and if I'm using mouse, then it's pretty easy for me to just go to the scroll bars and come all the way to the top. Whereas if I'm using touch and I'm scrolling, at some point I can get to the bottom very easily, and then if I want to go back to the top, I have to pan and flick and pan and flick and pan and flick. And that's usually much harder when you're on the phone, too. So the scenario that I'm going to focus on is to actually put a small go to top button on my list when I start panning with touch. If I'm using touch or pen, that go to top button will start to appear. If I'm using mouse, I don't want that go to top button to start appearing. So in order to build this out for me, I'm going to actually extend the state trigger base class, which we have opened up. And you can now create your own custom trigger. The custom trigger that I'm creating is called input type trigger. Let me add a little bit of snippet, and then I'll walk you through what it looks like to actually create an input type trigger. We have actually, in the process of trying out this extensibility in our framework, we have tried to build out a couple of different types of triggers, and we have come up with very, very simple steps in order for you to implement multiple different types of custom triggers. The steps are just 3 things that you have to think about. The first thing is whatever private variables you have, put them in there, and then you have to have your public properties that you want to set from XAML that you want to create in your trigger. In this particular context, the 2 properties that I want on my custom trigger are the target element and the pointer type. The target element will be the element on which I want to detect the type of input that is being used. In this scenario, the target element will be the list. And on my target element, I am going to quickly add the pointer pressed event handler so that I can now look up this event when it occurs on this particular item, and then I can actually check what was the pointer type that was used to interact with that particular item. So the second public property that I'm going to add is a pointer type, which is what is going to define for me whether this trigger is going to be active or not. I'm using an inbuilt enum that we have today on Windows Devices Input class, which is pointer device type. It has 3 values, touch, pen, and mouse. In my target elements pointer pressed event, I have a very simple logic where I am just getting the current input device that was used to interact with that target element. And then I'm using the setActive method on state trigger base class to actually tell the framework whether to apply this trigger or not. The setActive method takes a Boolean value, and by setting it to true, which it'll be this particular condition will evaluate to true if the current input device that was used to interact with that particular list is equal to the pointer device that was declared on XAML for that particular input type trigger. This will become even more clear to you when I actually use this trigger in XAML, and then you can put these pieces together. So the way I'm going to use this in XAML is I'm going back to my main page, and I'm going to add just a simple button called Go to Top button. It's just a button that I'm just going to overlay on top of my grid, so I'm just putting it loosely on my grid, and it just contains an image. By default, I'm setting the visibility of this button to collapsed. What I'm going to do next is actually use the trigger that we just created. So here's a snippet that shows how to do that. So what you can see here is that I haven't saved this guy, so it's not able to detect it. What you can see here is that I'm using the input type trigger that we just created, and I'm using the 2 properties that we added to the input type trigger, which is the target element and the pointer type. The target element is going to be the activity list. I'm using the new feature that we introduced called x:bind. I think Sam Spencer and Chipalo Street had a session yesterday which went into a lot of detail into it. If you didn't check it out yesterday, I would strongly encourage you to check out the video. It's a new feature which is similar to binding, but it's much more improved. I'm using it here in the form of an element named syntax. So I'm going to find the activity list, which is the list of items for me, and I'm going to bind it to this element, and that is the element that is going to be passed to my custom trigger. And I'm also saying that this particular trigger needs to be applied when the pointer type is touch. You will notice that I have a second trigger statement here. This kind of multiple trigger statements are allowed inside a state triggers. And what this means is that this behaves like an OR condition. So what this means is that this particular visual state will be applied if touch or pen was used to interact with the activity list. So when one of these two, if either touch or pen is used, I am going to have a setter statement, which basically toggles the visibility of the Go to Top button. And if you notice, I'm also using a storyboard here because I want an animation. So for animations, we still want you to use storyboards and double animations here because I don't want the button to just become visible. I want it to have a nice, smooth animation to make it visible. So we allow inline usage of both storyboard and setter syntax along with state triggers inside visual state at this point. So putting it all together, let's take a look at what this app has become at this point. I want to showcase both the scenarios that we just built out, which is the first scenario of having a view model-based trigger, where I want my commute-based activities to be highlighted in a different color. I also want that when I'm interacting with my activity list, a button to show up that actually shows me a different Go to Top button to show up if I'm using a touch. So here, you would see that here we see that Tim had a commute-based activity over here, and it's showing up in light green highlight. You would see that that happens across the board whenever there is a commute-based activity. And all the other ones are not highlighted. So this is our view model-based custom trigger taking into effect. And you will see that because I'm interacting with this list in mouse, I'm actually not seeing a Go to Top button. So the minute I start interacting with touch, you would notice that there is a Go to Top button right over here in orange. So as long as I'm interacting with touch, it's going to show up. And when I start interacting with mouse, it goes away. So this is our custom input type trigger in action.
Good. So that was just 2 examples of things that you can do to basically extend the trigger mechanism. One simply being the state trigger of just saying, yeah, the state is going to be active. So again, a more declarative way of just setting the Boolean property of go to state, basically. And the second showing how to extend that trigger definition. Here's the example of the snippet that we just saw there. Is basically we're providing a state trigger base. And the key there is the set active call. You need to tell the framework when it's active. All the other logic is completely up to you, what you want to do with it. And then the usage, of course, of this is simply just kind of like a custom control. So I just put kind of the namespace mechanism up there. And then you define your triggers the same way that you would the built-in ones there. So the key for extensible triggers is we're providing a simple base class in the framework for you to extend. You define the logic. You can combine any triggers that you want. You can see that even in the triggers, you saw that Harini had 2 of them. So it kind of provides OR conditioning for you there. We want you to think about those things as well. So as you're even within custom triggers there, you can combine some of the multiple features. So we have a new feature for improved performance when UI is not going to be showing. We call that X defer. So if you're doing something that you may not need a lot of UI, maybe you have a trigger that says, I'm not going to show this UI under this condition. And in your trigger, you can kind of realize those elements so that they're not created behind the scenes and that consume more memory and things like that. So these are just some examples. And Harini's put together an SDK sample that all our Windows SDK samples are up on this GitHub. This is the URL directly to this one with some examples of some more custom extensible triggers. But again, we love our insiders as well. And so Morton's here. I'm going to give a plug to Morton. So he spelunked the SDK early on. And he also has a set of custom triggers. And probably he's going to need a pull request because the API changed a little bit from when you started it. But he's already doing it. Yeah, yes, he's already submitted. And so anyhow, it's good to see the community involved in discovering the things that that we've developed and appreciate those things. So getting back to our key message, what we've been able to demonstrate is that through using a real app that was a phone-based app that we can run it on the desktop, and just by using simple things as well as we get the built-in capabilities and extending our platform and keying off very simple things, like you saw that even in our usage in this consumer-based kind of fitness app, we actually didn't need to know that we were on a quote-unquote phone. We didn't actually need to do any of that feature detection. One might say, hey, well, that's a GPS tracking app. that might be a great example of where you probably want to do the feature detection to make sure that there's a GPS device available before you hit, start recording or things like that. You don't have to detect that, am I on a phone? Making the assumption that a phone is the only thing that has a GPS device is no longer a valid assumption. So we want you to focus on the UI thing, on window sizes as the primary thing that you pivot off of. And we've done the work within the XAML framework to hopefully make that a lot more flexible declaratively for some things that you could do today, and introduce a couple more concepts that make it easier to lay out your UI. Now let's talk about tailoring your experience. So we realize that there's a lot of scenarios out there, and like we've been able to demonstrate in this app, and actually if you look at all of the inbox apps that we ship within Windows 10, like the Photos app and the Store app and things like that, those are also universal Windows apps, and they are one package, one binary, and they have responsive UI within theirs as well. There's very few that don't, and there's some technical reasons why they don't. But for the most part, you'll see that a lot of the apps are universal Windows apps as well. And they use the same concepts that we've introduced here. They're not doing anything different as a Microsoft app that you're doing. But there may be some needs where you want to actually tailor your experience. I would imagine there's some ISVs in the audience that you're custom control developers. And so you're providing things that people are consuming within their apps. That would be probably a good scenario where you want to use some of the more advanced APIs to detect some things like the continuum mode. If you're not familiar with the continuum mode, that was some of the examples that were demonstrated in the keynote. And there's actually a session later today, I believe, about continuum mode, where your mobile phone application can leverage an external display and keyboard and device and things like that. So as a control developer, you may want to be able to detect, am I in this tablet mode? Is my primary interaction mode touch versus keyboard? Those are the type of things. To do things like the XAML framework did in the menu flyouts and those other things to be able to detect those input types. So that's a very highly tailored scenario as a control developer as well. We also think that where API information things are not sufficient, first and foremost, we want you to tell us where that is not sufficient. So use the feedback tool. If you're seeing the inability to check a capability, we want to know about that. We don't want APIs to be special anymore. This is defined as the universal Windows platform, and we want to make sure that things go across there. But there are some scenarios that you may want to have an incredibly highly tailored experience for. We think of those, we don't think of those as like desktop and phone uniquely. Some good examples might be the larger experiences. So you saw the Surface Hub experience, where you have an 84-inch touch screen in a meeting environment where possibly multiple people are actually interacting with it from different angles and things. And so that's a completely different user interaction model that you may want to tailor very, very specifically to that. Xbox might be another one, more of a 10-foot experience, and you want to do something more unique with that interaction model. So we do have the capability of we're not going to demonstrate that today, but if you have questions about it, we're happy to talk about it. To show a little bit more flexibility in providing these unique, specific views, we think this is really, really the few will be doing these type of things. And we really want you to think first before you feel you have to jump into this mindset here. Some other examples of where you might want to tailor your views is, we want you to think about deciding your scenario and what is really driving the decision of why you want to tailor your view. Again, a lot of the times we hear people talk about, well, I need to know if there's a hardware back button. We have a converged navigation mechanism in the Universal Windows platform, so you don't have to think about a hardware back button anymore. You just have to think about back. You want to detect, sensors. Well, any device can have sensors now, so you just really want to, again, detect if you need a specific sensor, not assume that the mobile platform versus a desktop platform has those things you need. So really ask yourself, the second you say, I need a phone view, ask yourself why you think you need a phone view and why these APIs aren't going to be sufficient for you. But if they are, you want to create those unique views for those and load them appropriately. So we have a little snippet of things here. So Harini had talked about one-handedness as an example. And that is a pretty good one. And so when you think about one-handedness, that's not necessarily always about the phone. It's more of about a physical size of something that you're holding in one hand. So using an API to detect kind of a diagonal physical size might be able to say, oh, I'm in a very specific one-handedness mode, and I want to do something different there. And so that might be something that you want to trigger off. As an example, the Photos app, this is not the Photos app, but this is an example of that. But the Photos app does something similar like this as well. On the desktop, they have primary navigation using the split view, but on the mobile phone, in one kind of, or one-handedness thing, the navigation is more close to your thumbs. So that's an example, and they use a pivot view as well. So that's an example of where you might want to tailor specifically to those needs. So again, with that, our call to action to you is to create and or migrate your apps to the Universal Windows platform. We want you to leverage Visual Studio and the tooling features that the tools team and the engineering teams work together on to provide you with designing your view and showing it in multiple different sizes and multiple different devices and be able to kind of get that design view. We are in a beta, and so as those tools will improve, especially around some of the controls and stuff that we've introduced, those will get better over time of helping you design within Relative Panel and things like that. We want you to think first about window size and pivot on that primarily. That's why we decided to ship that adaptive window size trigger in the box. But again, if there's other needs that you need to pivot on, we've created an extensible platform for you to create those triggers on. We're actually really interested to hear what people will extend those on as well. So we want you to use those capabilities, use Relative Panel for some better, simpler layout, and really kind of give us the feedback. And so we want use the feedback tool. The Windows feedback tool has a developer platform section in there. There's a lot of wacky stuff that comes in through that section. I don't know how, but you guys are all developers, so I approve that you can use that. But give us the feedback there. That goes actually directly to our team, and we are listening. So we want to make sure that you guys, we hear your feedback, and we can iterate over time with this new model with shipping Windows. So we thank you for coming this afternoon, and we have some time for questions as well. So if you do have a question, please come up to the mic. But I appreciate you coming, and we'll be happy to hang out for questions afterwards as well. So thank you very much. Oh, remember to fill out the evals, and then here's our list of sessions that are kind of related to this topic as well. So thank you. Hey, Colin.
Hi, Tim. I'm just wondering, do you expect people to use kind of attached properties and to simplify a lot of what I've seen? I saw a lot of XAML. I thought a lot of behaviors there that maybe you could kind of encapsulate in attached properties in some way.
Attached properties as far as like some of the triggers and things?
Yeah, well, you've got still quite a lot of XAML there to do some things. And maybe, do you expect people to simplify into attached properties? And is that maybe something you might supply as examples?
Probably not in this release, I don't think. It's definitely something, like I said, we're kind of interested to see what people will use these for.
Okay.
To see.
All right. Thanks.
Any other questions? We'll hang out up here if you're too shy for the microphones as well. All right, thank you. You have a question? Okay, good. Thank you, guys.